Here's an AKAI AM-2950 that a fella dropped off, and he wants me to bring this thing back to its former glory. He wanted me to go through it and check all the caps and stuff like that, and pull the odd one here and there and check for ESR and all that kind of stuff. And all the caps seem to be pretty good, at least all the ones that I've pulled, and the ones that I've tested in circuit seem to be a-okay. The main bolt caps are holding their charge once this thing is shut off for a very long time. So that's one thing to be leery about if you're ever working on one of these things and you shut it off. If it is working properly, the capacitors, these big guys over in this corner over here, they hold a charge for a very long time. You don't want to come across that. That'd give you quite a good buzz. So over 100 volts across both of them. So you have to be very careful. So the dial lights are shot on this thing, and somebody's already been in here and tried to replace them. You see right here, these guys have been added, and there's two bulbs that illuminate this also. Now I'm not going to put incandescent bulbs back in because with now modern technology there's no reason to do that, and you don't have to go inside the amplifier for a very long time. If you put LEDs, it's pretty much good for the life of the amplifier. If you don't overdrive the LEDs, they'll pretty much last a very, very, very long time, so you don't got to go back in anymore. So that's what I'm going to do. I'll probably design a small circuit board that will sit up in here, and it'll illuminate the meters from the top. Now what they've done is they use that kind of light channel piece of plastic here, and what happens is that it kind of has a fiber optic effect and carries the light over into the meters, and that doesn't work very well. The meters are very dim and everything, and I find that if I install some LEDs just right above the actual meter, it lights it quite evenly if you diffuse the LEDs, and the meters are very nice and bright. And it's the same with the dial here. Some brand new bright LEDs will make that light up really vivid green. It looks really nice. I've pre-lit it up with just some LEDs and a battery. You can see over there in the corner I've got some high brightness LEDs and just a couple of watch batteries, and I pinch it together and I move it around the meters and stuff and try and find the sweet spots before, of course, I go and design anything. So I know where I'm going to put the LEDs and how the meters light nicely, and also how I'm going to do the dial here. So I'll design a small circuit board, as I say, that'll sit up in the top, and that should do the rectification, because the stock dial lights on this run on AC, and you usually can tell that they're on AC because they twist the wires together. That's common practice whenever you're running long runs of AC wires. They're always twisted. So when you see twisted dial light wires in units, usually you know that they're on AC at that point. I've double checked the schematic, and sure enough they come right off of it. Looks to be, if I remember correctly, I'm not looking at the schematic right now, I think it's an 8-volt winding. This AKAI amplifier has incandescent bulbs for the factory display. So incandescent bulbs light the meters and the actual volume control. There's a plastic piece around the volume control that illuminates, and it's kind of a pretty thing that they've done. It looks really cool when it's lit up. But all the incandescent bulbs are burnt out, and in order to make this dependable so that it doesn't have to have bulbs ever replaced again, we're going to replace those incandescent bulbs with LEDs, and I'm going to design a small circuit board that will run these LEDs, and it will also dim them so you can match the brightness of everything, and just if you want to have the meters a little bit dimmer and the volume control a little brighter, he can set all this in the future if he wants to do that. So in order to make this circuit work, LEDs run on DC, and we need to rectify that AC voltage coming out of that power transformer. And how we're going to do that is with a diode. And this little diode here is a Schottky diode. It's a DL5818. And this little Schottky diode is supposed to be able to deal with a maximum RMS voltage of 21 volts and a peak reverse of 30. So I've got a whole roll of these things, and I've never really used these in a project, and it would be nice to verify these diodes just to see how good they are. So what we're going to do is test one on the curve tracer and look at it on the oscilloscope here at the same time. So what I'm going to do is start turning this up. Now this oscilloscope is set for 10 volts per box this way, so half a box is 5 volts. And this is set for 10 volts a box this way, same thing, half a box is 5 volts. So I'll start turning this up, and when we see the curve start to do a knee, we know that we're at its breakdown. You see that right there, it's breaking down. right there, it's that's a really sharp breakdown. So right about there is where it's starting to break down. So we count the boxes, we've got 10, 20, 30, 40, 50, and a half and a bit. So probably about 56 or 57 volts is where it's breaking down. So now if we look at this oscilloscope here, this is the peak voltage being applied to that diode. So we can count 10, 20, 30, 40, 55 and a bit. So there we can see it. It's 55 and a bit volts. So probably 56 or 57, like I said, in that area is where it's breaking down. Now that greatly exceeds the specs of this diode, so I'm not at all shy to use these diodes in this circuit. The RMS voltage that's going to be applied to this is about 9 volts or so, and the diode says it's good for 21. So and the peak reverse voltage is 30 is the factory, and we can see that it's breaking down at roughly about 57 volts. So it's, as I say, greatly exceeding its spec. So as you can see right there, it starts to break down as it goes vertical. So it's always just as it starts to go vertical is where you want to measure it from, because that's where it's starting to break down. So really right about there, and that's about 56 or 57 volts. So these diodes are overachievers. They're made by Microsemi, it says. I got a whole roll of these things, and they're rated at 1 amp, so that greatly exceeds what the current specs that all of these LEDs are going to be running off of. So these guys are good to go. What you see here is the LED circuit for this AKAI stereo power amplifier. This is a breadboard, and this is the proving ground for the circuit before I actually go and design a circuit board. So I've designed up this small circuit here, and I'm just making sure that everything is working properly before I design that circuit board. So I'll give you a quick rundown of how everything works. You'll recognize this cord from the previous video, the dim bulb tester video with a variac. This is supplying 8.7 volts AC to this circuit right now. Now, the power transformer inside the AKAI stereo power amplifier supplies 8.7 volts AC to all of the incandescent bulbs inside the amplifier. So all this is doing is mimicking that supply. So when I put this all together and put it inside the AKAI, I'm not going to get any surprises. You recognize this rectifier diode here. This is that Schottky diode that we did the little curve tracer test on. This is the filter cap for the supply. These are 2 current limiting resistors for the LEDs. This is a bleeder across this cap, a 1K ohm resistor, so that when I shut the circuit off, the LEDs go off rather quickly. This IC you see behind here is what's doing the dimming control for the LEDs. This is the dimmer, the pot, 100K ohm pot. This N-channel FET here is a slow-on circuit with an RC network in the gate lead of the actual N-channel FET. So when you first turn the circuit on, this capacitor has to charge through this 220K ohm resistor, and of course it takes a while to charge because this 220K ohm resistor is forming a form of divider with this 100K ohm resistor, so the tantalum comes up slowly. And I'll demonstrate that here in just a moment. So I'll turn this dimming control up so that we can see it's not really dimming anymore. Look at how bright that is. That's crazy bright. That hurts my eyes. That's so bright. So that's about 30 milliamps per LED. And this is down. You can see it's nice and gradual with the control. So we can dim each meter and make each meter look exactly identical in brightness. And that's the whole idea of this circuit here. So I'll turn the LEDs up just a little bit. Now I'll turn the circuit off, and you'll see that the LEDs go off rather quickly. The circuit is going off now. So they kind of fade out nice and quick. Now what's happening is this bleeder resistor is discharging this cap, and of course this tantalum is discharging right now. So when I turn the circuit back on again, this tantalum will charge slowly, and this N-channel FET will be in the linear region for a very short period of time, and you'll see these LEDs slowly come on. So I'll turn the switch on right now. See how slow they come on? It's kind of a nice added feature when you're turning the amplifier on. And of course it makes it nice and easy on the circuit, and it does look kind of nice too when you have that slow little ramp up. So that's what this circuit does. Now there's only 2 LEDs being shown here. There will be another 4 LEDs. There will be another 2 on the other meter, and there will also be 2 in the volume control. And they will also have, each one of them will have their own little dimming pot. And of course all of that will be surface mount. The only things that really won't be surface mount in this circuit are this cap here and this IC, and of course the LEDs won't be surface mount. But all the other components will all be surface mount components, so it'll be nice and compact. So what we're going to do next is look at the actual AKAI, and I'll show you where I'm going to put this small circuit board and what the process is to figure out how to build this circuit board and to fit it in that little compact area. Here's the face of the AKAI, and these are the 2 meters that we're going to light up. And this is the ring around the volume control that we're going to light up also. This ring kind of has a light carrying effect, kind of like a fiber optic effect, and it lights all of the numbers up on the plastic dial here. It really does look quite pretty when it's lit up. And the meters, when you shine the LEDs down on the meter, not using this light channel that they've done, when you actually shine the lights right down into the meters are very vivid, and it looks quite a bit nicer than the stock setup. Now you can see in the stock setup here they have, this was supposed to be 1 incandescent bulb, but somebody's hot glued 2 smaller bulbs in here. But there is an incandescent bulb that would shine in the center here, and this is kind of a light channel, carries it over the top of the meters, and very dimly lights the meters. So in a dim setting, you will see the meters light up kind of that golden incandescent glow factory-wise, but it is still very dim, and the lights need to be very low. So now by putting the new LEDs in here, these really light up a vivid green color, and the same with this ring around the volume control here, and it really does look quite a bit nicer. So let's take a look at this actual area here and how we're going to build the circuit board. Here we have a little bit closer view of how this light channel is working here. So we can see that this is a piece of plastic, and the lights kind of fit down into this area here and shine their light, and then it reflects through this light channel. Well, as I said earlier, it's kind of dim that way and doesn't really look all that good. These are the wires from some of the old incandescent bulbs. Let's move them out of the way. This here, you can see there's kind of a concave here. This kind of comes up and then it goes down on this concave. You can see there's 2 little green dots here, and that's right about where the LEDs have to be in order to really light that meter evenly to get a nice glow. So it'll be the same. I'll measure these areas with a caliper, and I'll also mimic that on this side above this meter. So I'm going to mount the circuit board with this screw here and this screw here. So what I'll do is I'll measure the centers, and I'll use that as a guide for when I'm designing the circuit board. Now the circuit board will be a little square board that will fit right in here. Now it can't sit up very high because this isn't very deep. This is maybe 1.5 inches deep or so. And we also need to have that filter cap in here, and of course the lid's right here, right? So what we'll probably end up doing is removing these light bulbs here, and there's a nice hole that goes straight through and straight down. So what I'll probably do is mount the filter can right here, and that filter can will just go right down through that light hole, and there'll be lots of room for the filter at that point so that it's not limited by hitting this here. So I'll measure the centers here, and I'll design a circuit board that's appropriate. Now this is just a shield that comes off. I can remove this shield back here by undoing this screw here and this screw here, and it looks like that these centers are pretty close to the same centers. They're probably the same size, or they've measured these to the same. They look in line with each one. So I'll double check, and I can use this as a guide. I'll probably just remove this shield here and use it as a guide. Now I have some aluminum standoffs that are threaded, and I'll probably just re-thread these and thread the aluminum standoffs in here. So I'll have some standoffs so the circuit board will fit above this piece of plastic here, and I'll probably mount all the components on the top of the circuit board here, and I'll have the LEDs so with a little bit of wire lead so that I can move them around a little bit and focus them just perfectly inside the meters to make these meters look very nice. So, and what I'll probably also do is run the wiring out through this hole, because it looks like there's probably enough room in here to get the cap and probably the wiring to run out. So we have to run a couple of wires over here to the volume control. So I'll probably put the feed-in wires through this hole and run the wires out, and that'll keep it nice and clean. You'll just see a circuit board here. It'll actually be cleaner than the stock build because they've got wires and stuff strapped to the back here and running around and hanging out. So the whole idea is not to decrease the value of the thing, but it's to increase the value and make a really nice looking professional build. So that's where I'm at this point. So now I'm going to go over to the computer and start drawing the circuit board, and I'll measure these centers and start figuring out component placement and exactly what components I'm going to use. I think the majority of the components for this circuit board will be 1206 parts. There might be the odd 2512 part, and then of course the IC is a regular through-hole part, but I'll kind of surface mount that. and the VRs will be very, very small surface mount VRs, and they'll be able to be set, and I'll probably label them, and you know, one for this meter, one for this meter, and one for the volume control. Here's the circuit board in its beginning stages. So I've measured up the distance between the actual stock mounting screws and measured this all up and put this on the circuit board so I can get an idea of the actual size of the board. This is the meter centers here, and this is where the LEDs are going to mount. The sweet spot was 25 millimeters apart. So moving them closer and further away creates forms of shadowing and this kind of thing. So 25 seemed to be the sweet spot for lighting the meter evenly and for the all-round best look. So the actual measurements are right here on this piece of paper. The centers are 124.2 millimeters apart from this side to this side, and from these two mounting screws it's 15.6 millimeters. Now I'm not going to use these. These just are going to hold the cowl on, but they helped for actual measurement purposes in order to get everything else working. So there's quite a bit of measuring with a caliper and rulers and all sorts of things to try and get everything all perfect. So this is what I've come up with so far right here, and this is just for my sizing. So what I do is I take this, you know, I print this off on the printer here, and then what I do is I take this over here. So here's the face of the unit, and it's kind of a neat little feature. I have some really, really thin circuit board, and what I'm going to do is is just mimicking the circuit board here. It's a piece of paper. The circuit board is going to fit into the face like this, and the face is going to support the front end of the circuit board, which works very well. They left a little bit of a gap there. So this is the cowl here that sits behind here like so. It's kind of hard to do with one hand holding the camera here. So I'll just put this on here. Like so, and like so. So that just fits on there like that. And then this circuit board is going to fit in here, and then of course you can see where the actual standoff is. That's going to mount to that little pad right here, and then this little pad will mount to the other standoff, and that will sit in there like so. And these LEDs are very close to this face here, but just far enough back that it works perfectly with the lighting. So that was a little bit of measurement and fun trying to get this all working like so. So if we actually take this cowl off again, and I find my flashlight over here in my mess, you can see under here, turn the light off, you can kind of get an idea of where the centers are. So if I shine this under here, you can see the pads. I don't know if you can see that, how far back there. They're just a little bit a ways right here and here. They're just a little bit a ways from the front of the unit, and that's enough space for the LED, the actual plastic case of the LED, so that it doesn't touch the face. And I want them as close to the face as possible. I might even angle them towards this piece of reflective steel here. There's a piece of reflective steel here, and I find that if I angle the LEDs towards, it kind of shines evenly down into these meters. So that's how this is going to work. These have been tapped to a different screw size here so that I can use the standoff. Where's my tap here? I think I've got my tap over here. You can see this guy here. I tap the screws here to 632. I believe that's the size. Yep, 632. I remembered my screw size there. I have a million taps and I'm using them all the time, so sometimes they get confusing. 440, 632, all these different ones. So anyways, that sits in there like so, and these standoffs will bring the circuit board up just to about the right level here. And it will tuck right in there, and everything will be pretty good. I have extra space here now that I've removed this this light tunnel here. I don't need this. This doesn't hold the meters in or anything. All it does is it's supposed to reflect the light, and it's actually a lot brighter without the light tunnel. So when you put the LEDs in there, they really light up nice and clean and very bright, brilliant green. So, and this gives me a little bit more room for the caps. I don't have to worry about fitting them down this center hole here. Here's the finished layout on the computer, and I'm ready to make a circuit board now. I do the toner transfer method, so this program will mirror this so that when I feed it through my little special laminator there, it'll come out the right way up. If you ever do this, make a circuit board or something, and you do the toner transfer method and you forget to mirror it, it's kind of frustrating in the end because you get a backward layout. But anyways, here it is, and this is the dimmer / light controller and LED board for the actual AKAI. So now this is on a piece of paper here, and what I do is after I finish it off, I draw and print all the values and do some drawings on here and all that kind of stuff. And that way when I actually go and populate the board, I can have this in front of me and it makes the population kind of nice. So here's the actual circuit board is done. So this is done with the toner transfer method, and it's pretty much ready to go into the unit. So it's already been pre-drilled and everything, and now I just have to go and populate this. I usually do that by the microscope or under the microscope, depending whatever's more comfortable. And this will go inside the AKAI and we'll be ready to try it out. I'm ready to start populating the board here. And I've got two 1206 parts right here and right here. And I use these kind of a bent anti-magnetic stainless tweezer in order to pick the parts up because it allows me to work under the microscope and hold the parts. I usually move the circuit board in the way that I'm going to mount the part so I can hold the part sideways like so. So the solder area is on this end. So you can see that. So I try not to solder the components this way unless I absolutely have to. It just makes my life quite a bit easier to do it like so, because I can come in this way with the soldering iron and then tap it and kind of work like this under here. And that makes my life a little bit easier. I do use RA type flux. This is an RA flux, and that I put a little bit on the pads before I start to solder. And what that does, that really helps the component tack itself down. So I have a soldering iron and the tip is just wetted. So this is the iron here, and it has kind of a curved tip you can see at the end. And as I say, it's just wetted right at the end there. So what I do now is I take this, like so, put it onto the pad, usually touch the top just to make sure it's flush, and I make sure it's square under the microscope. And then I just touch it like so, and then that resin really helps to wick up to the pad, and see now that component is stuck there. So that's one that's tacked, and then I'll tack this other one here the same way. There's still enough solder left on the tip of this iron that it will tack this part. And the whole idea is to make the components even on the pads so that they look really good too, right? Then I take a little bit of extra solder and I tack the other side now, because if I touch the other side the component will come off. So there's that side there, and then there's this side here, and then I go back and I touch up the other sides like so and like so. And then those two components are now on there. And the whole board is basically done in the same process. The ICs and stuff are kind of held, and if the pads are you know, this way, I'll work, or I'll, you know, because I have components that mount both ways on this board, so I'll move the board around. And this piece of foam that you see here, this just helps the board to stop sliding around. It's like a sticky kind of a mat. It's a rubber that's kind of an adhesive, so it really holds it. Like, it's not actually sticky to the touch, but when you put something on it, it holds it, and that makes it really nice, because when you're trying to work with something and the board's pushing around with the tweezers or something, it really gets quite frustrating. So what I'll do is I'll finish populating this board here, and when I'm done, I'll come back and show you the populated board. Here's a circuit board all done and installed in the amplifier. You can see it's all populated now and everything's wired up. The wires come in the bottom, and the filter cap sits right on the other side and goes down. So you'll see that there's a bit of a light glare on the tracks. So there is no coating on this circuit board aside from the the circuit traces being tin plated, so the light kind of shines on the tracks a little bit, glares, and makes some of them look a little wider than they are. But that's just I guess the tracks reflecting into the screen of the camera there. So you can see the little VRs right here. This little VR here and this little VR here sets the brightness of these 2 meters. Right below here is an LED, and right below here is an LED for this meter here. And then of course right in the center is the center of the meter. And same thing here, that's one LED for the meter, and this is the other LED for the meter. And then back here it says VC dim, that stands for volume control dim. So that little VR dims the volume control on and off. Here's the that little FET that slow starts the metering circuit. And this is the tantalum cap that charges and gives us the delay. That's the bleeder across the main filter cap here, and there's that Schottky diode we tested. This little IC is what's doing the dimming control, which dims both of these, allows them to have a nice smooth dimming action when we use these VRs. And these resistors are the what sets the current limiting for the actual LEDs. So it'll allow the LEDs to pull about 24 milliamps each or so, and that's where it kind of tops out. And that's really the circuit board in kind of a quick explanation. You see the circuit board goes forward, it actually goes about this far into the face, so the front of the circuit board is completely supported by the face here, and then they're mounted to those 2 standoffs that we saw earlier. These 2 little rubber grommets here just put a bit of tension on the actual back side of the metering circuit by removing that light channel. That light channel pressed down and gave it kind of a stop to stop the meters from coming back, and it was a little bit loose to begin with. So now this is puts quite a bit of tension on here, and they're very tight. So that worked out really good. This is just a rubber grommet kind of cut in half and then slid down in there, and that worked out very well. The LEDs for the volume control are over here, and I'll have to do that off camera because I have to kind of come in from this side here. So I'll do that in the next shot and show you the LEDs in there. This is the back side of the volume control, and you can see where the LEDs are tucked into those factory green boots. There's one there and one there. This black and white wiring is soldered and heat shrunk onto the back side of the LEDs. The black and white wires are the factory wires, and I just repurposed them for these LEDs. You can see it's tied off to the same point here, and the other side is also tied off. That's the main supply for the board. And the supply for the board is derived from these 2 orange wires right here. So those 2 orange wires are what supplies all the AC voltage for this board, and it gets rectified on the board, and that supplies the LEDs with the voltage that they need. The LED board is now fully installed and wired up inside this AKAI amplifier. So now we can look at the lighting system. You'll notice the camera's on a bit of an angle here, and the reason it is because the lighting from the room is kind of casting a reflection on this piece of plastic here. So I'll turn the amplifier on, and you can see the LED lights. So you can see what a pretty vivid green color that is. That really adds to this amplifier. And you can see the meters, how nicely they light up. Now keep in mind, the factory incandescent bulbs were nowhere near this bright. In this particular light, it would be barely perceivable. So you can see how that really sets this off. LED lights really do make quite a difference in this era of amplifier and tuner too. They really just, put the icing on the cake. This is really quite dim still. So what I can do is I can turn it up and give you an idea of what it would look like turned up a little bit. That's about halfway. That's about halfway right there. And I'll turn up the volume control to match. So you can see there's lots of brightness there. When I put my hand over the box here, you can see how much light is actually just reflecting in that box. The LEDs are on the other side of the circuit board, and they're firing down. And this light that's coming up is actually just reflected light. So there's lots and lots of light there. These are high brightness type green LEDs. These are a wide angle LED, and these ones here are a narrow angle LED. So you can see how bright that is. I'll turn it back down to something that's a little bit more reasonable, I would figure, for kind of everyday use. I'd say right about there. That'd be pretty suitable there. And I'll turn the volume control down to match. You see, it's a complete range. I can shut it right off. You can see that. Turn it right off. Or I can bring it right up to full brightness, but I'll just match it right now. So there you go. That's a pretty close match, I would think. And that would be a happy medium for just, a normally lit room. And that's the difference that LEDs make when you put them inside of these amplifiers and tuners alike. How crystal clear and vivid that display is. So that's that. This project's done. I hope you enjoyed following along here. If you did, stay tuned. There'll be more experiments and circuit builds in the near future. Bye for now.